Hello and very welcome everyone to this session of the World Geography, Weather and Climate Part 2. In today's session, we are going to discuss the topic and we'll see that how this topic will help us in our upcoming exams. So let's start. Before we start, the images, text and other materials used in our presentations are for educational purpose only. We respect and intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathi@irtk.ac.in and we shall remove the same. So let's start with the thing that we need to discuss is about the climate, weather and climate. So climate is average weather conditions of a specified area for a considerable time. That is called a climate. And if we talk about the this phenomena, so it will change over a very large period of time. That is for approximately 200 years or 300 years, the climate will change. So that is a phenomena that takes time. Then weather pertains to the condition of the atmosphere in any place or any time. So if you are living in any city, then the weather will be different, and about 10 kilometers or 20 kilometers away, the weather will be different. So that depends upon the different place and different time. Now let's talk about the pressure belts one by one, and we'll see that how they are formed and what are the phenomena because of which these pressure belts occur. So first is the subtropical high pressure belt or horse latitude. That is that the latitude of 30 to 35 degree north and south. The corresponding latitudes of subtropical high pressure belts are called horse latitudes. This is 30-35 degree north and south, and why they are called horse latitude? Because of the absence of air. It was hard to move the ships during the modern time when the sailing was started, navigation process was started, and near about this area where the horse traders used to put the horse back into the sea so that they can uh, light up the weight of the ship. So that is because this latitude has got the name horse latitudes. After saturation, complete loss of moisture at the intertropical zone and convergence zone, the air moving away from the equatorial low pressure belt in the upper troposphere becomes dry and cold. So as the air rises at the ITCZ, it rises up in the troposphere and cools down when it reaches the troposphere, the height of the troposphere. This dry and cool wind subsides at 30 degree north and south. So after rising up at 0 degree, it will be diverging on both the sides. One moves towards 30-35 degree north and one moves towards 30-35 degree south. And when they reaches 30-35 degree north and south, they starts to descend. So the high pressure along this belt is due to the subsidence of air coming from the equatorial region, which descends from after becoming heavy. So this is one of the reason, that is because the 30-35 degree north and south, instead of having the high temperature, they are having the high pressure because it is a dynamic belt and not a belt that depends only upon the temperature. The high pressure is also due to the blocking effect of air at upper levels because of the Coriolis force. So I hope the point is very clear that why the 30-35 degree north air area latitude has high pressure belt. Then the pressure belts, so the subsiding air is warm and dry. Therefore, most of the deserts are present along this belt in both hemispheres. So as we know that air is descending and a high pressure air is descending, and there will be no moisture present in it. Because of that, there will be no clouds, and the cloud and the sky will be very clear. Because of which no or zero amount of precipitation will be there in this latitude, and that is why the maximum deserts are found in 30-35 degree north and south region. This belt is frequently invaded by tropical and extratropical disturbances. That is a consistent thing because it resides in the area that is just parallel to the tropical region and also to the extratropical or temperate region. Now, equatorial low pressure belt or doldrums. So this area lies between 10° north and 10° south latitudes. And if we talk about equatorial low, because it is called with this name because of the high temperature, because of which the air rises and creates a low pressure area around it. Width may vary between 5 north and 5° south and 20° north and 20° south. This belt happens to be the zone of convergence of trade winds from two hemispheres from subtropical high pressure belts. So we all know that just parallel to this equatorial low pressure area, the subtropical high pressure belts rise on 30-35° north and south. And because of that, as we know that there is a pressure gradient difference, and because of that the air will flow from high pressure to low pressure. So the air that is blowing from subtropical high pressure belt to equatorial low pressure belt is famously known as the trade winds, because of the time when the navigation during the modern time, the navigators, they used to travel in this area, and they will use this air for trade purpose so that their ship can move. So that is why it got the name trade winds. And both the winds are coming from both the sides and are converging at the 0° latitude, that is the equator. This belt is also called the doldrums because of the extremely calm air movement. So as we know that equator is the area where the temperature is quite high, and because of which the whole air present in this area will rises. And as the air will rises, the space will become proper vacuum. And as it becomes proper vacuum, so after that what happens is that the particular area will have no air, and the ship, if we're traveling through this region, will experience no air. And because of that, they have to lighten up their ships by throwing their goods and commodities into the sea by filling them in the drums. So that is why this area got the name doldrums. The position of the belt varies with the apparent movement of the sun. Formation: as this region lies along the equator, it receives the highest amount of insolation. So this is really important, and do remember that this region is also known as ITCZ. And during the whole year, this ITCZ is the layer that travels from one place to another, from equator to subtropical to the tropical region, that is Tropic of Cancer, and then back to the Tropic of Capricorn. And because of that, this particular movement of the ITCZ, the winds will also travel from one area to another area. Now, pressure belts: due to intense heating, air gets warmed up and rises over the equatorial region. That is the convection. So convection is a phenomena in which the air gets warm up and moves from the surface towards the higher altitudes, and that is called a convection. Whenever there is a vertical upward movement of air, the region at the surface will be at low pressure and the above surface at high pressure. Thus, the belt along the equator is called a equatorial low pressure belt. Climate: this belt is characterized by extremely low pressure with calm conditions. Vertical winds: so convection carrying moisture form cumulus nimbus clouds and lead to thunderstorms. So that is the convectional rainfall. That is the phenomena type of a rainfall that occurs. Then the polar high pressure belt. So the polar high are small in area and extend around the poles. They lie around poles between 80 to 90° north and south latitudes. The air from subpolar low pressure belts after saturation becomes dry. This dry air becomes cold while moving towards poles through the upper troposphere. The lowest temperatures are found over the poles. Now let's talk about the subpolar low pressure belt. So located between 45° north and south latitudes and the Arctic and Antarctic circles, 66.5° north and south latitudes. These are dynamically produced due to Coriolis force produced by rotation of the Earth on its axis. So we can see that on both the sides of this pressure belt, we have found the high pressure area, like the polar high and the subtropical high. And another reason is that this region has the effect of Coriolis force that is increasing in nature. And because of that and presence of both the sides, the high pressure area, this subpolar region becomes the low pressure zone. So ascent of air as a result of convergence of westerlies and polar easterlies. So due to a great contrast between the temperature of the wind from subtropical and polar source region, extratropical cyclonic storm or low temperate cyclone or frontal cyclones are produced in this region. So from one side, from the subtropical side, subtropical high pressure belt, the westerlies are coming, and from the polar side, the easterlies are coming. And because of these two phenomena, as they converges on this part, that is the 60-65 degree north and south, the air starts ascending. And as it starts ascending, it also creates a cyclone that is called the frontal cyclone or temperate cyclone. So always remember that the subtropical subpolar belt is a low pressure belt, and this is the reason where the temperate cyclones also formed. Then general circulation of the atmosphere. So the air at the intertropical convergence zone rises because of the convection caused by high insolation and low pressure, that is the equatorial low pressure belt. The winds from the tropics converge at this low pressure zone. The conversed air rises along with the convective cell. It reaches the top of the troposphere and moves towards the poles. This causes accumulation of air about 30 degree north and south. Part of the accumulated air sinks to the ground and forms a subtropical high. Another reason for sinking is the cooling of air when it reaches 30 degree north and south latitudes. Down below near the land surface, the air flows towards the equator as the easterlies. The easterlies from either side of the equator converge in the intertropical convergence zone, and that is the area of equatorial low pressure belt. Such circulations from the surface upwards and vice versa are called cells. Such a cell in the tropics is called Hadley cell. So when the air rises from the equatorial low pressure area and reaches the top of the troposphere and starts moving towards subtropical high pressure belt, and this whole circulation creates a type of a cell. This cell is famously known as the Hadley cell. Then from subtropical high to subpolar low, another cell creates that is called the Farrell cell, and then from subpolar low to polar high creates another cell that is called the polar cell. So in the middle latitudes, the circulation is that of sinking cold air that comes from the poles and the rising warm air that blows from the subtropical high. At the surface, these winds are called westerlies, and the cell is known as the Farrell cell, as I was saying. At polar latitudes, the cold, dense air subsides near the poles and blow towards middle latitude as the polar easterly. This cell is called the polar cell. These three cells set the pattern for the general circulation of the atmosphere. The transfer of heat energy from lower latitudes to higher latitude maintains the general circulation. Now another one is the planetary winds. So generalized sketch of global atmospheric circulation. So here we can see that in this diagram, the circulation of the wind is clearly depicted, in which at the 0 degree latitude, the equatorial low pressure belt is found, that is ITCZ. Then at the 30 degree north and south and 30 to 35 degree north and south, the subtropical high pressure belts are found. And subpolar low is found at the 60 degrees, 65 degree north. And then on vice versa, on the other side also the similar type of structure is found. Now, this is the global atmospheric circulation that we already have learned in the earlier slides, and this is the depiction of it. So the wind blowing throughout the air from high pressure belts to low pressure belt in the same direction are called planetary or prevailing winds. So these are called the permanent winds as well, or the planetary winds or the prevailing winds, and this happens because of the presence of these equatorial pressure, because of these pressure belts that are formed on different latitudes. Due to the effect of the rotation of the earth, the direction of the wind tends to deflect instead of blowing directly from one pressure belt to another. These winds blow throughout the air and are controlled by the latitudinal pressure belts. They blow over vast areas of continents and oceans. So, because of these phenomena or these permanent winds, the lot of phenomena occur, like the monsoon occurs, like the ocean currents occurs, and some other effects are also happening because of these planetary winds. And that is why the climate of the earth is also circulated all over the earth. Now the main planetary winds are, so first one is westerlies. So westerlies blow from subtropical high pressure belt towards the subpolar low pressure belts. So if we talk about the westerlies, so they blow from 30-35 degree north towards 60-65 degree north. And we all know, because of the Coriolis force, when these winds will blow, they will move towards the right. And as we know that as we move uh, above from the equator or the equator latitude towards the pole, the deflection is much higher. And that is why it seems like that the wind is coming from the western side. So that is why the name is westerlies or westerlies. The westerlies of the southern hemisphere blow with greater strength and constant direction than the northern hemisphere. Under the Coriolis force effect, the westerlies becomes the southwesterlies in the north hemisphere and the northwesterlies in the southern hemisphere. Westerlies winds are named as roaring 40s, furious 50s, and screaming 60s, or sometimes also called shaking 60s, based on the speed of the wind in the southern hemisphere. Because there is absence of landmass, and because of which there is no obstruction for the winds that are blowing, and that is why when the winds at 40 degrees south, 50 degrees south, and 60 degrees south they blow, they create a lot of noise, and that is why they are named as roaring 40s, furious 50s, and screaming 60s. Polar easterlies. So the polar easterlies are dry, cold prevailing winds that blow from polar high pressure belt to the temperature low pressure belts. There are extremely cold winds as they blow from the tundra and ice cap regions. The polar easterlies are more regular in the southern hemisphere than in the northern hemisphere. Unlike the westerlies, the polar easterlies are often weak and irregular. Another one is the trade winds. So trade winds blow in a belt lying between 5 degrees north to 30 degrees north in the northern hemisphere and 5 degrees south to 30 degrees south in the southern hemisphere. So there is a low pressure on the equator while high pressure at the subtropics. So air moves from the tropics towards the equator. The trade winds in the northern hemisphere blow from the northeast direction due to the deflection of the wind caused by the rotation of the earth, and so are called the northeast trades. Similarly, the trade winds in the southern hemisphere blow from southeast direction and are thus called the southeast trades. They are also known as the tropical easterlies. So they are called the trade winds. So trade winds, do remember, they blow from subtropical high towards the equatorial low, and on both the sides of the earth, that is on southern hemisphere and northern hemisphere, and it converges at equatorial low pressure belt, and this is the point where the whole air rises up, and because of that at the 5 degree north and 5 degree south area is known as the doldrums. Now another one are the local winds. So local wind is a type of a phenomena that is not the part of planetary winds or permanent winds, but they blow because of the different type of weather phenomena or seasonal phenomena occurs in different regions. So local wind occur on a small spatial scale, as I was saying. So main type of local winds are sea breezes and land breezes, anabatic and katabatic winds, and other local winds due to differential heating of land surface, as I was saying. So they depends upon the seasonal change. Land breeze. So night land cools faster than sea, that we all know. That is a simple phenomenon of science, that the land that heats up faster in the morning or in the afternoon cools down much faster in the evening with respect to the sea. So high pressure over the land and low pressure over the ocean winds. So blow from land towards sea. These are called a land breeze. Katabatic wind. So it is the generic term for downslope winds flowing from high elevation of mountains, plateaus, and hills down their slopes to the valleys or plain below. It is adiabatically warmed. Sea breeze. So daytime land gets heated, warm air rises up, low pressure develops, sea being less warm develops high pressure, thereby winds blow from sea to land, causing sea breeze. Anabatic wind, so air flow traveling up a facing slope of an orographic surface. So that is called the anabatic wind. So these are the different type of local winds that flows from high pressure area to low pressure area in different areas. The land breeze, the sea breeze, katabatic and anabatic wind. So when the air remains over a homogeneous area for a sufficiently longer time, it acquires the characteristic of the area. So that is the air mass we are going to discuss. The air with distinctive characteristics in terms of temperature and humidity is called an air mass. So any air particularly over any particular area that is present and they have different temperature and humidity. So on that basis the air mass is defined. It is large body of air having little horizontal variation in temperature and moisture. The main source regions are the high pressure belts in the subtropics, giving rise to tropical air masses, and around the poles, the sources for polar air masses. Areas with high pressure but little pressure difference or pressure gradient are ideal source regions for development of air masses. Tropical air masses are warm and polar air masses are cold. Air masses and source region. So there are 5 major source regions. These are the subtropical hot deserts, the relatively cold high latitude oceans, warm tropical and subtropical oceans, permanently ice covered continents in the Arctic and Antarctic, the very cold snow covered continents in high latitudes. So these are the different type of air mass and source regions that are found, and because of that the different type of air masses are found. Warm front, the contact zone where the warm air mass comes towards the cold air mass, that is called the warm front. Cold front, the contact zone where the cold air moves towards the warm air mass, that is called a cold front. So frontal rainfall generally occurs because of these two types of air masses. Occluded front, it is if an air mass is fully lifted above the land surface, that is called the occluded front. Stationary front, when the front remains stationary. Influence of air mass and world weather. The air masses carry atmospheric moisture from oceans to continents and causes precipitation over land masses. They transport latent heat, thus removing the latitudinal heat balance. Most of the migratory atmospheric disturbances, such as temperate cyclones and storm, originate at the contact zone between different air masses, and the weather associated with these disturbances is determined by characteristics of the air mass involved. Fronts, when two different air masses meets the boundary zone between them is called a front. Frontogenesis, so the process of formation of fronts is called a frontogenesis. So do remember all these things. Now jet streams. So jet streams are relatively narrow bands of strong winds in the upper level of the atmosphere. So jet streams are majorly found when the convergence of different type of air masses happens and a large amount of air mass remains in the top of the troposphere. Now remember they are found in the troposphere. The wind blows from west to east in jet streams, but the flow often shifts to the north and south. Jet streams follow the boundaries between hot and cold air, and the shifting of north and south of the jet stream towards north and south is because of the variation of the sun rays over the earth, over the year. Since these hot and cold air boundaries are most pronounced in winter, jet streams are the strongest for both the northern and southern hemisphere winters. The strongest jet streams are the polar jets, weaker is subtropical jets, and plays a very crucial role in the arrival of monsoon in our country, that is India. Subtropical jet streams. Lowest latitudinal jet stream present throughout the year gives Rossby waves, characteristics flows at lowest isobaric levels, dry weather conditions in the entire influence zone, and transports western disturbance of Mediterranean Sea. Shift northward during high sun season. However, the continentality of India causes exceptional bands and displaces this jet stream in Central Asia and replaces it with tropical easterly jet stream. Polar front jet stream is thermal indirect jet stream and is extension of polar night jet stream. This jet stream has well-defined life cycle. It occurs in between 40 to 60 degree latitudes. Polar night jet stream, highest latitudinal, thermal direct with very high velocity and on convergence zone above the subpolar low pressure belt. Then comes the local jet streams. So these are named after the local areas like the Somali jet. So the progress of the southwest monsoon towards India is greatly aided by the onset of Somali jet that transits Kenya, Somalia and Sahel region. It strengthens the permanent high near Madagascar and also helps to drive southwest monsoon towards India at the greater pace and intensity. The peculiar feature of Somali current is reversal in direction with the onset of the summer monsoon. Tropical easterly jet stream. So there are major high velocity winds in the lower troposphere called the low level jets. In the tropics, the most prominent of these are the Somali jet and the African easterly jet, that is the tropical easterly jet. The formation of TEJ results in the reversal of upper air circulation patterns, high pressure switches to low pressure, and leads to the quick onset of monsoons. The easterly jet come into existence during the high sun season in northern hemisphere and affects the occurrence of rainfall in India, ensuring 3 months of continuous monsoon-laden wind. Tropical cyclone feature of a cyclone. So it is a large system of wind that circulates about a center of low atmospheric pressure in the counterclockwise direction, north to of the equator, and in the clockwise direction of to the south. So the direction, the circulation in clockwise and anti-clockwise direction is because of the presence of Coriolis force, and because of that, as we know that in the northern hemisphere the wind moves towards right, and in the southern hemisphere they move towards the left, and because of that in northern hemisphere the circulation is anti-clockwise, and in the northern hemisphere the circulation is anti-clockwise, and in the southern hemisphere the circulation is clockwise. Cyclonic winds move across nearly all regions of the earth except the equatorial belt because of the absence of Coriolis force effect. So there will be no cyclone formed at the equatorial belt. So anticyclone wind systems that rotates about a high pressure center. Anticyclones have a flow opposite to that of the cyclones. That is on the outward spiraling motion with the winds rotating clockwise in the north hemisphere and counterclockwise in the southern hemisphere. And do remember that anticyclones are formed over the 30-35 degree north and south region, and this is one of the regions because of which the sky in 30-35 degree north and south remains clear, and it is one of the phenomena because of which the deserts are formed majorly in the 30-35 degree north and south. So these are called anticyclones and they are just opposite to the tropical cyclones. Conditions ideal for the formation of cyclones. So sufficiently warm sea surface temperatures higher than 27 degrees Celsius. This is the ideal temperature. Atmospheric instability. High humidity in the lower to middle levels of the troposphere. Enough Coriolis force to develop a low pressure center. a pre-existing low-level focus or disturbance. Low vertical wind shear. Upper divergence above the sea level system. So the first thing is required is the temperature, that is about approximately 27 degrees Celsius or higher. And after that, a low pressure system should be created in the center. And do remember that one more point that you can add is the ideal condition is that in the closed space. So generally the tropical cyclones are formed in the closed space regions of seas, and not in the open seas, and that is why major cyclones that are found or formed over the year are formed in Bay of Bengal and not in Arabian Sea. Energy source of cyclones. So the temperature difference between the warm rising air and the cooler environment causes the rising air to become buoyant, further enhancing its upward movement. The fuel for a tropical cyclone is provided by a transfer of water vapor and heat from the warm ocean to the overlying air, primarily by evaporation from the sea surface. An anticyclone, as a high pressure area, is a large atmospheric circulation system with the wind flowing clockwise around it in the northern hemisphere and counterclockwise in the southern hemisphere. Anticyclones form from air masses cooler than their surroundings, leading to contraction of air, making it denser, thereby increasing surface air pressure. Calm, settled weather is usually synonymous with anticyclones in temperate latitudes. Anticyclones are typically relatively slow moving features. So these are the important aspects of anticyclones. Remember them. Formation, polar front theory. So the warm humid air masses from the tropics meets the dry cold air masses from the poles, and thus a polar front is formed. The cold air mass is denser and heavier, and due to this reason the warm air masses is pushed up. This interaction of cold and warm air masses creates instability, and a low pressure is created at the junction, particularly in the center of interactions. And thus a void is created because of lessening of pressure. The surrounding air rushes in to occupy this void, and coupled with the Earth's rotation, a cyclone is formed. And this type of cyclone or frontal formation is known as the temperate cyclone or extratropical cyclone. And this is one of the reasons because of which the western disturbance also occurred in the northwestern part of India in the winter season. And generally, these phenomena occurs at 60-65 degree north and south, and during the winter season this area lies over the Mediterranean Sea, and hence Mediterranean Sea water and works as a source of energy for these type of cyclones as well. Temperate cyclones and polar front theory come under the head of temperate cyclone. Here they are given under the subhead of tropical cyclones. They are also known as extratropical cyclones, where the term extratropical signifies that this type of cyclone generally occurs outside the tropics with a latitude range between 30 and 60 degrees. They occur more strongly during the winter season. Jet streams influence path of temperate cyclone. They are caused due to the front formation. Stationary front, when both warm and cold air masses are in front of each other, causes frontal precipitation. Frontogenesis, so convergence of warm and cold air columns is called frontogenesis. So these are the phenomena because of which the temperate cyclones are formed. Stage of division of front. So this generated division in temperate cyclone cold front, part of cold air mass penetrating is warmer air latitude, causes thunderstorm. Warm front, part of warm air mass penetrating in colder latitudes, has increased temperature and slight precipitation, and has cirrostratus clouds. Cold sector remaining part of cold air mass, warm sector remaining part of warm air mass. So that is called a stage of division of front. Quick shift of cold front. Closing down of warm sector. Stage of occlusion. merging of warm and cold front. It has a mixture of cold front type and warm front type weather. Frontolysis, death of temperate cyclone where warm air has completely rised and cold air and completely subsided. Now, the temperate cyclones, so difference between the tropical and temperate cyclones. So on one side we have tropical cyclone. So tropical cyclone developed in intertropical convergence zone due to the differential heating of land and sea. As the ITCZ migrates to tropical and subtropical latitudes and even beyond during the respective hemisphere summer season, increasing Coriolis force make the formation tropical cyclones with this zone more possible. Tropical cyclones form between 5° and 30° latitude. So as the sun moves or the sun rays moves vertically from equator to Tropic of Cancer or Tropic of Capricorn, similarly the formation of cyclone also varies. The wind decreases with height. The eye of the cyclone is characterized by light wind and clear skies. The eye wall is where winds are strongest and rainfall is heaviest. Tropical cyclones have strongest winds in the lower troposphere near the top of the boundary layer. These cyclones have much more intense rainfall than temperate cyclones, isobars in complete circles, and the pressure gradients is steep. Center of cyclone is hotter than the surrounding area. On the other side, we have temperate cyclones. So temperate cyclones are formed in mid latitude between 35 degrees Celsius and 65 degrees north and south. So temperate cyclones are found between mid latitudes between 35 degree north and 65 degree north and south. So these are the areas in which the temperate cyclones are generally formed, and that is the reason of the subpolar low pressure area. The wind increases with height. These cyclones have rising air at the center, which results in clouds and rain. Temperate cyclones have strongest winds at the top of the troposphere in the core of the jet stream. These cyclones tend to have much more moderate rainfall, still destructive enough to cause flooding. Isobars are usually V-shaped and the pressure gradient is slow. So these are the differences between the tropical and temperate cyclones. Now, El Nino Southern Oscillation, that is also known as ENSO, it is a type of a phenomena that affects the monsoon in our country. So, Indian monsoon mechanism. Monsoon are seasonal monsoon laden winds peculiar to Indian subcontinent, Southeast Asia, parts of Central Western Africa. Mechanism. So, differential heating of land and water, intense heating of Tibetan plateau causing bend in ITCZ. This shifts the whole pressure belt system, making the equator shift 5 degree north to actual geographical equator, also called as the monsoonal trough. The southeast winds from the subtropical high pressure belt travel to reach ITCZ and change their direction to southwest after crossing the equator due to Coriolis force. These winds are attracted to Indian subcontinent owing to the low pressure generated over Tibetan plateau, causing burst of Indian monsoon. So Indian monsoon majorly is affected because of ITCZ, and these are the type of a wind that blows from the sea or the Indian Ocean towards the Indian subcontinent. And the different type of phenomena that affects this monsoon, one of them is the El Nino Southern Oscillation, that is the ENSO. Subtropical westerly jet is replaced by subtropical easterly jet stream. The winds pick up moisture while traveling over the sea and drop it over the Indian subcontinent. The Indian monsoon is divided into Arabian Sea and Bay of Bengal branch. Due to shift of monsoonal trough, there occurs break in Indian monsoon for a short period of time. Now, retreating monsoon, so are also called as the northeast monsoon. They are caused by formation and strengthening of high pressure cells over Tibetan plateau and Siberian plateau in winter, westward migration and subsequent weakening of high pressure cells in the southern Indian Ocean, migration of ITCZ to the south of India. So as soon as the ITCZ starts traveling from the Tropic of Cancer towards back to equator, the particular monsoon that arrived in India also starts following it and it is also famously known as the northeast monsoon. So majorly South India, especially Tamil Nadu, receives December rains due to retreating monsoon. India receives rainfall through three ways. Southwest monsoon, that is a regular monsoon that comes in June. Then northeast monsoon, also called a retreating monsoon, that starts from the northeastern direction and flows majorly towards the eastern side of India. Then western disturbance, that is the temperate cyclonic precipitation that affects the northwestern part and causes snowfall and rainfall in the month of December, January, February in northwestern part of India. El Nino and La Nina are opposite phases of what is known as the El Nino Southern Oscillation Cycle. The ENSO cycle is a scientific term that describes the fluctuations in temperature between the oceans in the east central equatorial Pacific. So if we talk about the El Nino and La Nina, so during the El Nino time, the drought-like situation occurs in India, and La Nina time, the flood-like situation occurs in India. So we'll talk about them more. So let's talk about El Nino first. So it refers to a periodic warming in sea surface temperature across the east central equatorial Pacific with rise in temperature of more than 0.5 degree Celsius. That means the area around Peru. That is the point where you will find the surface temperature of ocean getting warm up. The warm ocean conditions in the equatorial Pacific induce large-scale anomalies in the atmosphere. Rainfall increases manifold in Ecuador and northern Peru, California causing coastal flooding and erosion, and severe drought occur in Australia, Indonesia, India, and southern Africa. And the meaning of El Nino is the Christ child, and why it is called El Nino, because it is like a boon to the people boom to the people of living in western part of South America because it brings rainfall for them. El Nino event occur irregularly at 2 to 7 years intervals. Strong El Nino events are associated with droughts in Indonesia, Australia, and northeastern South America, and with altered patterns of tropical storms in the tropical belt. El Nino is negative for Indian monsoon. Then La Nina. It is a cyclic counterpart to El Nino. That means it will bring a lot of rainfall and causes flood in India. So consisting of a cooling of a surface water of Pacific Ocean along the western coast of South America. So earlier in El Nino, it was getting warm up, and now in La Nina, it is getting cooled up. So La Nina has less effect in Europe, but it does tend to lead to milder winters in northern Europe and colder winters in southern western Europe, leading to snow in the Mediterranean region. Elsewhere in the world, areas that are affected by La Nina experience the opposite of the effects they experience with El Nino. It does not occur as often as El Nino. It causes abnormally heavy monsoons in India and Southeast Asia and winter drought in southern USA. Then Madden-Julian oscillation. So Madden-Julian oscillation is the largest element of the intra-seasonal variability in the tropical atmosphere. Unlike a standing pattern like the El Nino Southern Oscillation, the Madden-Julian oscillation is a travel-ring pattern that propagates eastward through the atmosphere above the warm parts of the Indian and Pacific Oceans. This overall circulation pattern manifests itself most clearly as anomalous rainfall. Heavy tropical rainfall associated with the MJO shift eastwards from the eastern Indian Ocean to the western tropical Pacific. Now, Indian Ocean Dipole. So, the Indian Ocean Dipole, also known as the Indian Nino, is an irregular oscillation of sea surface temperature in which the western Indian Ocean becomes alternately warmer and then colder than the eastern part of the ocean. The IOD involves a periodic oscillation of sea surface temperature between positive, neutral, and negative phases. The positive phase sees greater than average sea surface temperature and greater precipitation in the western Indian Ocean region, with corresponding cooling of waters in the eastern Indian Ocean, which tend to cause the drought in adjacent land areas of Indonesia and Australia. The negative phase of the IOD brings about the positive opposite conditions with warm water and greater precipitation in the eastern Indian Ocean and cooler and drier conditions in the west. The IOD also affects the strength of monsoon over the Indian subcontinent. The IOD is one aspect of general cycle of global climate, interacting with similar phenomena like the El Nino southern oscillation in the Pacific Ocean. El Nino Modoki strong warming in the central tropical Pacific and cooling in the eastern and western tropical Pacific. It results into two-cell Walker circulation. La Nina Modoki cooling of central tropical ocean and warming of eastern and western tropical Pacific. Walker cell circulation is caused due to the generation of high pressure system over the eastern Pacific Ocean and a low pressure system over Indonesia. Walker cell is associated with southern oscillation. And that's it in this session. I hope you learned a lot of things with me and gained great knowledge. I will meet you in the next session. Till then, bye bye and thank you.